Alrighty, so we've been having some trouble when we've been working with our exponential functions because although we can find the y-intercepts, the x-intercepts have been unsolvable. However, now that we can solve for to the power of x, that means we can actually work out. So what we're going to be looking at is finding exact solutions, and then we might spend a little bit of time approximating them to get ourselves an idea of how big these numbers should be. So I've got 3 to the x equals 7. So since I want x by itself, that means I would want to move the 3 from one side to the other. The only way I can do that is by taking log base 3 of both sides. Now, when I do that, remember that's going to cancel the log base 3 with the 3, leaving me with x is equal to log base 3 of 7. But now I've got a new question. How big is that? Now obviously I can use my calculator to determine the decimal approximation, but I guess I want to get us more of a feel of how big this number is. So let's think about how big is that? Well, my suggestion is to always use numbers that we do know. So what's log base 3 of 3? Well, that's really 3 to the 1. So log base 3 of 3 is 1. What's the next number that we actually know the log base 3 of? Well, it'd have to be log base 3 of 3 squared, or 9. Well, again, since that is 3 squared, that cancels, and we're just left with 2. So log 7, since it's between 3 and 9, must be in between 1 and 2. Must be bigger than log 3 base 3, and it must be smaller than log 3 of 9. Therefore, it's got to be bigger than 1, but smaller than 2. So that kind of gives us an idea. If I was drawing a sketch, for example, well, I now know I need to put it in between 1 and 2. We don't know exactly where along there, but it's got to be somewhere in that little range there. Alrighty, let's have a look at a different one. This one's a little bit more challenging. Alrighty, so first of all, we've got a -1 on the left-hand side, so let's take that from both sides. Take 1, take 1. So we're just left with 3x plus 3 equals 4. Alrighty, so if we want to get rid of the 3, now we're going to need to take the log base 3 of both sides. So let's do that. Log base 3 of 4, we don't know what that is yet, but the whole point was to get rid of the 3 on the left-hand side. So now we're left with x plus 3 equals log 3 of 4. Now, once again, problem, don't know what that is, but I still also haven't found x, so let's take 2 from both sides, take 3 from both sides, sorry. And I can't really combine these things together because remember, the subtraction index law only works when we're dealing with things that have the same base log. And 3 isn't currently being taken in that sort of way. So let's now work out how big is that. This is going to be our new game show. Obviously with a calculator, it's not too hard to work out how big it is. In fact, I'd encourage you to go through and type it. You will need to use the option button to find the log base anything, but you can actually work it out. So how big is that? Well, let's just first think about log 3 base 4. Let's not worry about the -3 just yet. Well, it should be bigger than log base 3 of 3, but it should be smaller of log base 3 squared, or 9. So it should be between 1 and 2. Except, remember, we weren't actually solving for that, we were actually solving for that -3. So let's take 3 from all 3 bits of the inequality. That's going to give me -2 is less than log 3 of 4 minus 3. is less than -1. And so we now know that if I'm drawing this as like an x-intercept, it's got to be somewhere in here. Don't know where exactly in there, but it has to be between -1 and -2. Alrighty, so there's a little bit of exact values of logs. If you need to show how to use the calculator, I'm more than happy to help out. See you then next time. Bye.